All right, this is 2019 paper 2 BGCSE physics question number 4. Says the table below shows some information about the electromagnetic spectrum. Sorry about the quality of this one. It's a little fuzzy, but hope you can make it out. Okay, so first thing that I'm going to do is fill in what's missing because that's what we're asked in the first 2 questions. So after radio waves comes microwaves, then infrared, visible light, and then UV, X-ray, and gamma rays. So the radiation at A, that's microwaves. The radiation at B, those would be UV rays, and UV stands for ultraviolet rays. Okay, so done with those 2. State 1 use of X-rays. Okay, so we have a couple we can think of. I'll put about 3. So X-rays are used in body scans. So for medicine, we use them at airport security, checkpoints, to scan luggage, and they're also used in cancer treatment. Okay, so imaging / body scans, airport security, cancer treatment, any one of those you can remember, and that'll be fine. Okay, so we just earned 3 points. It's moving right along. State 1 harmful effect of X-rays on living organisms. Okay, so we just mentioned, ironically, even though they're sometimes used to treat cancer, they can also cause cancer. So they can cause cancer, so growth of abnormal cells. That's one very real risk. Then we're asked to state 2 properties that all electromagnetic waves have in common. So there's a whole list of these, about 9, but I'll list 2. So they all travel at the speed of light. And just to be safe, we're going to actually put what that value is. So that's 3 times 10 to the 8 meters per second. And they are all transverse waves. That's another one. You can also, just to throw an extra one in here, can travel in a vacuum. Okay. All right, so the diagram, part C. Diagram in part C shows wave fronts in water waves approaching a barrier. Okay. The wavelength of the waves is 2.0 centimeters, and the barrier has a gap that is 1.8 centimeters wide. Complete the diagram to show the diffracted wave fronts after passing through the gap. Draw 4 wave fronts. So, first thing you want to know, remember if the gap is small compared to the wavelength, then we get diffraction. If the gap is large compared to the wavelength, then we get straighter waves, less diffraction. Okay, more diffraction, less diffraction. This happens when the wavelength is greater than or equal to the gap size. This happens when the wavelength is less than the gap size. Okay, so large gap, small gap. let's look at the scenarios that we have in part C. So we're told that the wavelength is 2 centimeters and the barrier has a gap that is 1.8 centimeters. Okay, so in this case, 2 is greater than 1.8, so that's a smaller gap. So we expect that we will have some curving significant. So we're going to draw 1, 2, 3, 4 curved waves. Okay, let's look at the second situation. We have wavelength of 1.2 centimeters, and it's passed through the gap in part C, and so the gap was 1.8. Gap 1.8 centimeters. So in this case, the wavelength is less than the gap. So we have a large gap. Large gap means we have pretty straight waves. Okay, so no curve. All right, and that's what we should have. And so give one conclusion that can be drawn from your observations in parts C and D. So we're just summarizing what we said that we looked on. All right, so we can summarize this as the greater the gap compared to the size of the wavelength, the less diffraction occurs. And that's the end of question 4.